Okay, guys. So this week, welcome to your first official day of virtual learning, I guess, since we are finally able to start doing some new content. So this week, what our main focus is going to be on is solving systems of equation using the elimination method. It's the last set that we have, and all those, the first time we did it by graphing, which was if you had two slope intercepts. Then we spent a lot of time focused on solving by substitution, which we reviewed last week. So that's when you have an equation that's in slope-intercept form and in standard form. Well, this week elimination deals mainly when we have both equations in standard form. And what that looks like would be if we had like two equations that followed this format. Okay? And that's what we're dealing with. The thing about elimination is it relies on us being able to use this concept called scalability. Okay? And all scalability is that as long as I multiply each factor or each piece of the equation by the same number, it doesn't change my equation. So like if I had an equation, let me erase this real quick. So let's say my equation is, we'll say 2x plus y equals, or actually let's just get rid of this. Let's just go to, instead of having y, let's just say 2x plus, we'll go plus 3 equals 19. So that's my equation, and I solved it. This is the concept of scalability. So if I just solve that, I'm going to move my 3 to the other side. That's going to go away, and I'm left with 2x equals 16. Divide both sides by 2. Now I've isolated my x, and I would have x equals 8. Okay? That's the normal way of solving it. Okay? I didn't use any scaling. I just used what was given to me. However, scalability says, let's get rid of this guy. Okay, and we're going to bring everything back. Okay, scalability says if I multiply everything in that equation by the same factors, let's just use a factor of 3 in this case. So I'm going to distribute that to everything in here, and I'm left with 6x plus 9 equals 27 equals 57. Okay? Now, it's a common thought that says, well, since I multiplied everything through by 3, my answer should be bigger, or should be a scale of 3 bigger. However, when you actually work it out, what we find is we minus 9 from both sides. That's going to go away. And I'm left with 6x is equal to 48. Okay? Divide both by 6, divide both by 6. X equals 8. So what we find is that no matter what number, as long as I multiply everything by the same amount, my scale forces my answer to stay the same. It doesn't change my problem if I'm just making it bigger, as making everything bigger by the same number or by the same multiplier. You can't add everything. It doesn't work with addition. This only works when you scale using multiplication. Okay? So that's the concept we're going to be practicing. It's kind of a hard concept for some 8th graders to get right out of the gate. So we're going to spend today just really practicing setting stuff up on that. So let's dive into it, our lesson real quick. So let me clear this because we got some notes. Now, I do have a flip grid that's going to be posted for you guys to work on today. But that's just for your work. I would just recommend taking these notes on your own. But it's pretty simple. So what we're going to do is we're just going to take this one equation, set of equations, so they are 3, I lied, it's 3x plus y equals 5, and we have 6x minus 2y equals 4. So I have those two equations there, and they're both in standard form, which means it's not an easy substitution. I could use substitution to solve this, but I'd have to solve for one of my variables first. It just adds a whole bunch of extra steps. So we're going to solve this, which is called solving using elimination. Okay? And the elimination method is when both are in standard form. That's the easiest one to use. And all I'm going to try to do is eliminate one of my variables. Now to do that, it sounds way more complicated than it is, but we're going to have to follow basically a 3-step process. Okay? And the first step that we do, so step 1 is called eliminate by scaling. At least that's what I call it, elimination by scaling. So I'm going to look at these two equations and I'm going to find out which one would I have to scale, or could I use the scaling method to get one of them to become the opposite of the one that's standing over in the previous one. So here, if we look at these two equations, right here I have a positive y and a negative 2y. So to make this positive y the opposite of negative 2, I have to multiply it by 2, because then I'd have 2y, 2y minus 2y equals 0, so that would eliminate that factor. So what I'm going to do is take this first equation here, and I'm going to scale it by a factor of 2. Bring everything in here, and I'm left with 2 times 3x is 6x, 2 times y is 2y, and 2 times 5 is 10. So I just scaled my first equation by a factor of 2, which means it's not going to change it, just scaled it by a factor of 2, and I'm going to bring back my other equation here. And what I've done is I've created a situation now by scaling that causes my positive 2y and my negative 2y to be stacked on top of one another as opposites. Okay, that's step 1. You find which one you want to eliminate by scaling. I'm setting up this one here to eliminate by scaling. Okay, now we are going to erase this stuff up here. Okay, because now we're going to be at step 2, which is combine the equations. Okay, so I'm just going to take my 6x plus my 2y and I'm going to write it up under here in my step 2 of how to solve these. And we have 6x minus 2y equals 4. And I'm going to use this extra space down here, okay, to just erase. Now, what we're going to do now that we've got one that's set up to eliminate, we're just going to what's called combine the equations. And when I say combine, I'm talking about we're just literally going to combine or add them together. That's what we do. It allows us to do that because we know that the values are going to be the same for both of them. So if we know the x value is going to be the same and the y value is going to be the same in both equations, that's what makes it equal. That's what our solution is. We can do that. It's kind of a modified math hack almost is the way to think about it. And that's why we always teach this one last, because it only works in standard form, and this is really the only clear case that it makes sense to use this method. So we solve by elimination. So I'm going to combine, which is just add my two equations together. Okay? So I'm going to go 6x plus 6x, and that gives me 12x. These two eliminate. Positive 2 and negative 2y, they eliminate, so it just goes away, and I'm left with 12x equals 14. Okay? And then all I'm going to do from here is divide both sides by 12, divide both sides by 12, and I'm left with x is equal to 14 12ths, or it simplifies into 7/6. And that's what my x value is. Okay? And I'd be done with solving that for elimination, at least through this combining the equations part. Okay? The final step, just like before, is plug your answer back in and solve for y. Okay, so in this case I would take my x and I'm just going to plug it back into one of my two equations. And this gets a little more complicated. It's not as simple as it is when you have one in slope form. But if we did it real quick, Yeah, we still have room here. So if we did it real quick, we would just take our 6 times 7, 6 plus 2y equals 10. So that first equation, then this becomes 42 over 6 plus 2y equals 10. That becomes 7 plus 2y equals 10. Move my 7. 2y equals 3. So y is 2/3. Okay? Now, that's kind of an ugly one. I like to use ugly ones as my examples. The nice thing is they usually are just like the substitution and just like graphing, where we're not dealing with ugly answers, we're dealing with pretty answers. So those are our 3 steps. So we have our step 1 is figure out which one you want to eliminate using scaling. So elimination by scaling is step 1. Step 2 is combining and solving for x. So combine the equations. And then step 3 is just plug whatever it is back in to solve for the other variable, and you're done. And that's kind of what we're dealing with when we're solving systems by elimination. Okay? I hope you took some notes on that. Again, so I'll be doing Facebook Lives Tuesday, Wednesday, Thursday this week. We'll be doing them, starting them at 11, probably go till about noon on it. And I'm just going to go work through any of the problems I assigned. So the thought process would be you get the problems by about 9 in the morning, you have some time to work through it, figure out if it's making sense, if it's not making sense, and then I swoop in on Facebook Live and I'm just going to walk through whatever problems I assigned, just boom, boom, boom. You also have your flip grids to turn in every day, where you're just holding up your paper to the camera after you hit record, and it just records your work real quick in flip grid, so I can go back and take a quick look at it, make sure you're on the right track, or at least doing it, because this is literally work that you just have to do to get the nuts and bolts of it. Thursday, I will be doing a quiz review up as your assignment for the day, and then on that Facebook Live, I'm literally just going to go through like the main problems that you'll see on the quiz, and then Friday you're going to have a quiz. I do have office hours today from 1 to 2. They will be on a Zoom. I will post the Zoom on my website. I'll have it up probably by, well, the sooner the better. I'll probably have it up by 11 o'clock today. The Zoom details for that meeting, but I won't start it until 1 o'clock, and then I'll just be live from 1 to 2 to answer any questions that you guys have. So, again, we're going to be working through this. You're not done with this. This is just the overview of it. We're going to be practicing this all week long. So, with that being said, good luck, guys, and check back in today's work. I'm just having you do the step 1 of each problem, so it shouldn't be too bad.